So I wanted to try to cover lathe planes, y-axis cross face and cross face sub planes. This is something that took me about 2 years to learn. There isn't anything publicly available. What I've got is this part here that has various services that I basically designed to demonstrate some machining operations and planes combos. So you can see the part. I got a scallop on the back side, I got a cross milling operation back side, I got a face or cross operation on the front face. I have this helix bore that's offset, and a peel milled and finished flat on the side of the part. And here's what it looks like when it runs, to give you an idea of what that looks like. And we'll drop the speed just a little bit so that you can actually see something happen here. It roughs, finishes, puts on the flat, so the cross turn, does a cross helix bore. Then we do the flats with a face milled operation to demonstrate those plane combos. Peel mill the flats here on the side of the part. And here, I'll give you a little speed. Then we'll bring it back down and try to get the view orientation for the other side of the part. And we come in and 2D contour the face scallops in y-axis, and then cross mill the little feature on the back side of the part. So that's the gist of what we're doing. And basically the best way to explain these operations is that the lathe menu in Mastercam has this kind of hopeless little dialogue of shitty operations that might populate properly or might force you into a call with the reseller, where you basically become the idiot who trusted one of these buttons to try to do something with the software. And that's not fun. And these are all C-axis, like it's the 80s. People have y-axis machines now. So the y-axis operations use a programmer who understands planes and milling operations, which open up your ability to do all this stuff, you know, dynamic operations, thread milling, you know, 2D roughing, peeling, face mills, and multi-axis operations, which some of which work better than others in lathe, and some of which don't work in things like mill turn. But mill turn does help you out with planes, so you don't have to know this kind of crap. Anyway, we're 3 minutes into the video. Sorry for the waste of time, but we'll take a look at our first operation, probably, if Mastercam will cooperate with us. Okay, so we face, we rough, and get to the face mill operation. Okay, so the face mill operation is a cross operation. So the plane you need for that is this. Let me see, main face flat. That's what I made for it, and basically I have this little document I tried to figure out. So for a let me see, a cross mill in Mastercam, we need a copy of back with X pointing toward the main spindle and Z pointing the orientation of the tool coming in to do the work. So back looks like this, and our plane for that, let me see if I can find that, looks like, let me see, back, So that isn't, let me see, planes, main flat, front flat cross, okay. So main front flat cross is my plane, and back looks like this. So as you can see, we took a plane much like back, and we rotated it for main front flat cross. You can see the resemblance. So Z points at this plane, but the easiest way to make this plane is by clicking on this gnomon here, placing this plane, X points to the back, so we go X 90, and enter, and that didn't work, so I'm going to drop that. I'm in 3D. This is one of these nuances of Mastercam. Okay, first of all, I'm going to tell you that I learned the other day that auto cursor configuration needs to have these items selected, or I can't even work like I'm going to work in this video. This is one of the weaknesses of Mastercam. There really isn't a default setup that's functional as you install the program. So you have to know all these nuances. But you have to go into this menu here, get all these checked, like you see here, and also go to 2D mode, or it won't function properly. So now we click the gnomon, click the face, click the segment nearest the arrow, rotate, find out that we're going toward 90 degrees, type in 90, enter, click on the ball, and hit O for origin. But we have to have top selected, okay? WCS, really should be C and T probably, but WCS apparently worked right here. And that brought my plane to the origin, and then I named my plane something. And if I wanted to keep it, so for this instance, it was main front flat cross. So main front flat cross. Okay, so it was a copy of back, like I said. I didn't actually want to keep it, so I'm gonna delete that before I get screwy here. Delete. Darn it, just delete. Plane is in use. Okay, can't be deleted. Okay, so because they both have the same name, it thinks it's in use, even though it's or maybe it's this. I'm sorry. So it became active. Delete. So let me see. Is in use. Okay, main front flat cross. There we go. Finally get rid of the fucker. Alright, so that was how we made that operation. And that operation, we'll put the operations into another video so you guys can see how the operations were made. But for the purpose of the video, we're going to just talk about planes. And so my second operation was a helix bore, and that used on the levels manager the let me see, whole axis. All right, and so I created a plane that was again copy it back off of this geometry here. And so the way to create that plane would be plus button on planes menu. So this of course uses a coordinate system that's looks like back, but with Z rotated in to point at the top of this feature. The best way to create that is to go to plus, new plane from geometry, and we create a plane up here, and we select an orientation that has X pointed toward the main spindle. Because it's a cross milling plane, we green check, and we would call this main whole axis cross, like this. And then we would green check on that, click the gray ball, make sure we're in WCS top, and hit O on the keyboard, or auto cursor snap to origin. It won't drop down right now because it's not active. I'm not going to make the plane. So that's how we did that. And then we did a 2D contour of the face. Now the face rule is different, and so let's grab this plane rules. And so to face mill, duplicate right for main, X points at the geo center orientation of the feature being face milled to output C rotation properly. And so I'll bring this back into my other screen. And so in other words, we click right to take a look at what we're trying to create. So Z is pointed in the direction of Z positive, and we need X to point center of this feature here. So we'll grab a new plane, put it on top, click the segment nearest the arrow. Well, actually we could click this one too, whatever, and we could go 90, enter, get our X to be rotated 90 as well, enter, and then click the gray ball. We're in top, O for origin, and then we have a copy of, maintain a visual mental image of this. So you got Z this way, Y, X. I'm going to exit, and then we'll take a look at main face flat. And so we got Z, X, Y, and that's how we cut that feature. Then we're going to go to the PO mill on the side of the part. That's going to use a cross plane again, so it's going to look like back, with X pointed at the main spindle, Z in the orientation where we want the tool to come from to make this cut. And so again, we grab our dynamic gnomon by clicking on the gnomon, click on the face, and X has to face the main, so you go 90, enter. Everything else is then right. Click the ball, make sure we're in WCS top, O for origin, and that's going to look like, maintain a mental image, Z, X, Y. We're exiting out, and we're going to look at main second flat cross, and that looks just like that. Z, X toward the main, Y, and that functionally works. Now we get over to the sub spindle, and there's one of these planes I'm not 100% sure of, and I don't really know which one it is. I know that this first one is outputting 187 degrees. Now, these are the stupid things about the software. It'd be great if it just said, hey, this is C0, a little arrow out here. But there's no such thing. I derived from a blueprint and referring to the software and the output of the code that 0 is probably on this Y part of the top axis here. So that's 0, this line right here. And everything on the front is correct to that. Now on the front, on the main side, it never matters. You're always cutting a virgin part. It's all it doesn't matter where the hell Fanuc sees 0, as long as the other features are all oriented in relation to the first feature properly according to a blueprint. Well, not so when we get to the sub. When we get to the sub, these features have to have orientation to the other side, unless we do something screwy with our pickoff to fix it, which we can do. That's a bastard fix. But so our first operation on the sub is this scallop operation, face milling operation. And so forgive me, I don't remember what the rule was. So let's you know, and as I said, one of these planes is wrong, you know, or could be wrong. You know, Fanuc does some funky things. It's outputting 187 degrees for this feature, which is exactly 187 degrees in this direction, and it's outputting 90 for this feature, which is which is 187 plus 90 is 270 degrees, which is what this is from 0. And that may actually be the way FANUC wants to read it. So it could be correct output. I just can't, I don't know the rule, which is why, really you should have a reference material with the CAM package that explains how you check your code, because in C-axis I think a lot of people be confused. So we're on the sub spindle and we're doing face milling. So left we use a duplicate of left with X pointing 180 degrees from geo center orientation of the feature being face milled to output C rotation properly. So we grab our copy of left. We take a look at left for reference, and left is Z is going into the main spindle, and X would be what we'd orient toward directly away from the feature we're trying to cut. And so we'll go ahead and we'll take a look at that first, just for the hell of it. So here's what we end up using: Z toward the main spindle, looking like left, just like we just looked at, and X 180 degrees away from this feature. And the way we create that is by, let me see, I want to say I actually duplicated left. So I got left 1, then I edited left 1 by clicking the origin ball. That didn't work. Exit out. My left 1, edit. Maybe it didn't click for some reason because I wasn't right there. Okay, so steering the part around, I could go like this. Well, that's not an option anymore. I could go to top sub, WCS CNT. Then I grab my left 1, edit, grab my gnomon ball, hit O for origin. Now see, it came across, and now what I could do, click this segment nearest the arrowhead, and now with my settings, like I explained in the auto cursor configuration, this is working where it wasn't yesterday, and I had to talk to somebody about why is your software working different from mine, and he was able to help me out. I can snap to the center point of that arc. Then I can grab this middle segment and flip it 180 degrees. And enter. So I grabbed the segment. I began rolling it. I saw that it was going to a 180, now negative 180, and I typed 180. Enter. And now I could name the plane. I'm not going to, because it's going to look exactly like the next plane I show you. So subface scallop, here it is. Z toward the main, Y down, and X 180 degrees opposite this feature. And this output the code that gave me 187 degrees, and I think that's correct. Now I could be wrong on that one plane. There is nothing to check this against. So then my final plane, I used my lathe rules, and for cross milling in Mastercam on the sub spindle, I have a plane that looks like back with X pointing at the feature, with X pointing at the main spindle, Z pointing normal tool orientation of the operation. So with that in mind, we'll just take a look at sub cross mill, and so you can see it looks like back. We'll show you that in a second, but Z is facing this surface, and so this was a good so back. There's back, and here's cross mill, and so back is pointing toward the main, and all we did was sub cross mill was point our Z at the feature. But the easiest way to do that, of course, was to grab one of these guys, throw it up on there, make sure X pointed at the main, so negative 90, enter, and then grab the Gnomon ball, hit O on the keyboard with top sub selected. Now there's a trick for making all these operations, and there's the reference, same thing. There's a trick for making these operations, and that I learned today by running into the face tool not working. You have to know what plane you're going to use for the feature you're going to mill, and you have to make it WCS CNT before selecting the operation you're going to use, or that operation, such as the facing operation, might talk shit to you and not let you do the operation. So make those things active, and then when you're making the operation, you'll go to planes and it'll say main front flag cross all the way across. You got to grab top for your working coordinate system to tell the I kind of think of this program like a stupid slide rule sometimes, and the working coordinate system is what feeds it where the hell 0 is. So your code is going to come into negative Z for negative Z if this is right. This is going to orient your tool, these two. But selecting them will make it all the way across. You'll have to grab your top, for example. And in all cases, I had to use rotary type Y-axis. And that tells it, hey, output a rotation before cutting the code using the Y-axis. And so, you know, off the top of my head, you know, the only thing that I think, it doesn't even make sense to go there. You know, one of these things, this is a peculiarity, and I don't know the answer to it. You know, I have to check my other solution and see if that looked correct to know anything. And I think it was outputting 69 degrees or something like that for this feature, or 187. And 187 was something I could actually measure from origin 0, where the other tools were corresponding to on the main side. So I'm pretty sure this is correct. And this might be wrong, or it might be a fanicism that it gets to a certain point and fucking says, you know, rotate 90, I don't know. Anyway, I hope that helps. That's where I've gotten to in 2 years of using Mastercam on lathes like this. I mean, a lot of bastard shit happened to get code out of the program. I corrected a lot of C stuff. Did some stuff that wasn't, you know, perfectly on point. Sometimes made edits of the control. It would be nice for this to work a lot more smoothly than it does.